So next is block transfer external to external, that is transferring a block from the external RAM to a different location in external RAM. So let's see an example program. Write a program to transfer a block of 10 bytes from 5140 hex to 9384 hex. So we need to transfer a block of data from the location 5140 hex to a different location, that is 9384. So we need to transfer 5140 to 9384 both in external RAM. So the few things that you need to remember is that for the external data transfer, we cannot transfer directly from an external location to the other location. We need to move the data to the accumulator register and then move to the destination location. And the second point is that we can use only DPTR to point the external location. So we need DPTR to point the source address and DPTR to point the destination address. So but we can the DPTR, only one DPTR available for the 8051 microcontroller. So we need to store the source address and destination address in registers. So to store the destination address and source address, it is a 16-bit address. So the register holds only 8-bit address. So we use 4 registers to store the source address and the destination address. Can initialize 4 registers with the source 2 register for source address and 2 register for the destination address, and we need a register to hold the count, that is we need to transfer 10 bytes. So the count should be stored in a register so that the transfer operation from one memory from here to the accumulator and to the destination location. So transferring of first block to accumulator and then to the destination location. So this process can be repeated 10 times so that the 10 bytes is transferred from this from the source address starting from 5140 to the destination address to 10 locations starting from 3984. So to repeat, you should repeat this 10 times as we done for the internal memory. The same operation is happening here, but only thing is that we need to point the destination address with the DPTR register. So first we need to initialize the source address. To initialize the source address, it is 16-bit address. So the first the higher 8 bits, that is 51, is stored in R1 register and R0 register holds the second, that is the lower 8 bits. Lower bytes are in the R0 register and higher bytes in R1 register. So the source address is stored using initialized using R1 and R0 register, and the destination address, that is higher bytes in R3 and lower bytes in R2 register. So we initialize the source address and destination address in registers, and we need a register to hold the count, that is here we need to transfer 10 bytes. So the count is stored in R7 register, that is 10. 08 means it's 10. So we move DPTR. DPTR is a 16-bit register. So this DPTR this 16-bit DPTR is divided into 2 8 bits, that is DPH. The higher bits is DPH and the lower bit is DPL. So DPH and DPL, the DPTR is divided into 2 8-bit registers, DPH and DPL. So to point the first data, that is 5140, the higher bytes should be loaded to the higher byte should be loaded to the DPH and lower byte should be loaded to DPL. So higher bytes are present in R1 register, so we need to move R1 to DPH and R0 to DPL. So we move R1 to DPH and R0 to D. So the source address is now in the DPTR register. So we need to take the first data, that we move the data to the accumulator register. So here we use the accumulator MOVX instruction, that is we are taking data from the external RAM. So MOVX instruction is used. So now the data pointed by the DPTR, that is the location 5140, is now moved to the accumulator register. So next what we need to do, we need to copy this data to the destination, that is 9384. So to copy the data from accumulator to the location 9384, we need data pointer to point to this location. That means the DPH should contains the value 93. The DPH should contains the value 93 and DPL should contains the value 84, so that the DPTR will point to this location. For that, the 93, that is the DPH, is placed in the R3 register and DPL is placed in the R2 register. So from R3 we need to copy to DPH. So before that we need to store the value, or we increment the value, the current value in DPTR, that is 5140. So the next location is 5141. So that here we need to take the next value from 5141. So this value should be loaded to R0 and R1, so that we can the R0 and R1 points to the next location. So we increment the DPTR and move the DPH, that is 51 DPH to R1, and DPL, that is incremented, so it becomes 41, that 41 to R0. And next we place the new value, that is 9384, that is the destination address. That higher bytes in 93, that is 93, is placed to DPH, and lower byte, that is 84, is placed in DPL. So now DPTR is pointing to the location 9384, that is the destination address. So we need to copy the data to the destination address location. So we need the destination is at the rate DPTR, that is DPTR is pointing to the destination, and we need to move from A. So we write the instruction MOVX at the rate DPTR, A. So the data is transferred from accumulator to the DPTR register. So we increment the DPTR so that it points to the next destination address. When we increment, it becomes 93. So 93 is now placed in the R3 register, and 85 will be copied to the R2 register, the DPH to R3 and DPL to R2. So this process should repeat until 10 bytes of data is transferred from this location to this location. So we can use the loop this using DJNZ, that is decrement and jump if not 0, R7 register, where we store the count. So till R7 register becomes 0, this loop will be executed, that is the count is 10, so this loop will execute it 10 times. So 10 bytes of data is moved from from location starting from this address to location starting from this address. So to 10 locations the data is transferred. And then stop the program by using the loop. So this is a block transfer from external memory to a different location in external memory. So while handling with external memory, remember the point that therefore external memory we use DPTR to point the locations. So since both the source address and destination address is pointed by DPTR, first we use DPTR to point the source. We take the data and we increment the DPTR so that it points to the next location and place the value in the two registers. DPH and DPL is placed in these registers, and then the DPTR is loaded with the destination address. We transfer the data from accumulator register to the destination location, and then increment the DPTR so that it points to the next destination location, and this value, the value in DPH is moved to R3 and DPL is moved to R2 so that the register holds the address of next location. And this loop is executed 10 times so that we can transfer 10 bytes from this location. So the count, you can count can be directly given in the instruction, or you can take the count from a different memory location, or you can the user can directly input the count to the register. So you can use a particular memory location to hold the count, and that from that memory location we can copy the count to a particular register.